All right, so 51, we are still finding all solutions by factoring. And we've been given 2k squared equals 12k minus 16. All right, first things first, you'll recall from the previous video or two that we've done, we want to make sure that all of our terms are on one side and that our equation is set equal to 0. So let's go ahead and move these two terms from the right to the left and set this equation equal to 0 before we start. And so to do that, we can subtract 12k and add 16. So we'll subtract 12k, add 16, and when we do that, we end up with 2k squared minus 12k plus 16 now equals 0. Looks good. And now that our terms are on one side and our equation is set equal to 0, we can go ahead and go through the process of asking ourselves, how do we factor? So question 1, is there a GCF? And there is, right? We can go ahead and take a 2 out, and that leaves us with k squared minus 6k plus 8 equals 0. And now this looks like a nice trinomial for us that we can go ahead and factor. And we know it's going to turn into two binomials. And we're dealing with k, so let's go ahead and split that k up. And now we want to find factors of 8 that add to give us negative 6. Well, factors of 8, let's see, 1 and 8, 2 and 4. Well, the only factors in this list that can possibly add to give us negative 6 are 2 and 4. And what do the signs have to be? Well, let's see, negative 2 plus negative 4 does give us negative 6. So let's go ahead, put negative 2, put our negative 4 in, and there you have it. We've gone ahead and factored our trinomial, but we're not quite done yet, right? Because they want us to find all the solutions. And what that means is now that we have to take each of these factors, so all three factors, and set each factor independently equal to 0. So let's go ahead and do that. So we have now 2 equals 0. We have k minus 2 equals 0. And we now have k minus 4 equals 0. Well, the first one here, 2 equals 0, is the easiest one to solve because is this a true statement? Does 2 equal 0? No, sure doesn't. So we go ahead, and that's a false statement, so we go ahead and drop it completely. Don't even worry about it. But here, these last two, we can go ahead and solve for k, right? We can add 2 to both sides here, so we get k equals 2 and 2. And we'll add 4 to both sides here, and so we get k equals 4. And there you have it. We have solved and found all the solutions to this equation by factoring. All right, let's take a look here at 52. So we are given 4x squared minus 7x equals 15. All right, first things first, we want to make sure that all of our terms are on one side and that the equation is set equal to 0. So let's go ahead and subtract 15 from both sides. And that'll give us 4x squared minus, oops, not 17, but 7x minus 15 equals 0. All right. Now that we have all of our terms on one side and the equation is set equal to 0, we can go ahead and ask ourselves those two questions. Is there a GCF here? No, I don't think so. So question number 2, how many terms? Well, 1, 2, 3. So we know we're going to be using either the AC method or trial and error or scissors. I'm going to go ahead and factor this one by scissors. So we're going to look for factors of 4 because that's the coefficient of our squared term, and factors of 15. That's subtract to give us a negative 7. So what are the factors of 4? Well, 1 and 4, 2 and 2, and 15. Let's see, we have 1 and 15, and 3 and 5, and I think that's it. All right, and normally 9 times out of 10 we want to start with the factors that are closest together. So we would start with 2 and 2 and 3 and 5, but for the purposes of saving us some time, I know that 2 and 2 isn't going to work for us, and it's actually going to be 1 and 4 and 3 and 5. I don't remember which combination, but let's go ahead and see if we can figure it out. So let's go ahead and stack 1 and 4. We'll try 3 and 5. If 3 and 5 doesn't work, we'll try 5 and 3. So let's go ahead and, this is why it's called scissors, right? You're cross multiplying and you can create a little pair of scissors out of that. So 1 times 5 gives us 5. 4 times 3 gives us 12. Can we, in some combination, subtract these numbers, 12 and 5 or 5 and 12, to get a -7? Well, yeah, we sure can, can't we? So let's go ahead and get rid of that second possibility. And if we want a -7, what do the signs of each of these cross products have to be? Well, if this was a positive 5 and we subtracted 12 from it, we would get our -7. So we put a plus with our 5, so that sign just bounces over. Put a minus with our 12, so that just bounces over. And so now we've been left with, what letter are we working with? X. So 1x minus 3, or just x minus 3. And here we have 4x plus 5. 4x plus 5. And don't forget, that's been set equal to 0, right? Because we're working with an equation now. And now that we've factored our equation, our left-hand side, let's go ahead and set each of these factors independently equal to 0. So we have x minus 3 equals 0, and we have 4x plus 5 equals 0. And so solving here on the left-hand side, we will add 3 to both sides, and we get x equals 3. Here on the right, we'll subtract 5, so we have 4x equals -5. Divide by 4, divide by 4, and so x equals -5/4. All right, and there you have it. We have factored and solved this equation completely. All right, again, on a test, if you end up that it turns out you have a couple extra minutes, 5, 10, 15, 20 minutes early, you finish, do not leave early, right? Go back through and check each of your answers. So for these, you would take each of your solutions, plug it back into the original equation, and you should get a true statement. So when you take 3, plug it in for x, you should, this left side of the equation should evaluate to 15. When you plug in -5/4, this left side should evaluate to 15, right? Because equals 15. Here, number 51, when you take 2, plug it in, the left side and the right side should both equal each other. Same thing when you plug in 4, right? So that's a way that on a test you can check yourself, right? All right, let's take a look at 53 and 54 in the next video. I'll see you there.